In this video, we're going to talk about the laws of exponents, rules of exponents. Um, this particular website, QMath, likes to call them laws. It means the same thing. It's how exponents behave. Okay, well, let's start first of all with an idea of what an exponent is. Um, let's take, let's use a number first. We have a number 2, and then we have an exponent of 3. This is referred to as the base, and this is the exponent. Now, what does that mean? The exponent tells us how many times the base is to be multiplied by itself. So this is a shorthand for 2 times 2 times 2, and that's equal to 8. And of course we can do that on our calculator as well. We can do 2 and use this x raised to a box and fill in the 3 and hit equal, and we get 8. Okay, so it's just a shorthand for doing this. You can see if you had something like 2 to the 19th power, can you imagine writing that out and doing that longhand, where this is where you would certainly want a calculator. So if we have 2 raised to the 19th, that's going to be a pretty big number. We get 524,288. All right. So that's what they are. Now, when you're dealing with expressions in math, particularly algebra, where you have a number of expressions that have exponents, and you are adding, subtracting, multiplying, or dividing those numbers with exponents, they need to behave to a certain set of rules, and that's what these rules are explaining to us. So, let me erase this. And let's take a look at some examples. And one of the most common ones to be used, the two most common are probably the product and quotient. Product always implies the idea of multiplying. Quotient means that you're dividing. More jargon. Okay. Notice that the base has to be the same base. It's an A in both of these cases. So if I have x to the third power, we don't know what x is, and we're just writing expressions here, and I'm multiplying it times x to the fourth power, this is the same as if I have x to the 3 plus 4, or 7th power. So when the bases are the same, the exponents add. And in the quotient, if I'm dividing one by the other, I have x to the fourth divided by x to the third, they subtract. So this is equal to x to the fourth minus the third, or x to the 1. Now, anything to the power of 1, typically that 1 is not written. That invisible 1 bites us every once in a while, all over the place. So there's an invisible 1 in front of this x, for example, and there's an invisible 1 here. Okay. Then we have the power rule. If I have x to the second power, and I'm raising this whole expression to the third power, now this means the things multiply. So this is the same as x to the sixth power. Now, both these next two rules are kind of important because we oftentimes want to go back and forth between forms. If I have x and I have y and this expression is raised to the second power, that's the same as x squared times y squared. The two components inside get the same exponent. Okay. And notice that they do not have to be the same base. And sometimes for the sake of simplicity and getting things to cancel out, you want to go back and forth. So these two rules help with that. Here we can distribute this m exponent to both the numerator and the denominator, so we get this. And of course we can go backwards. Okay, the next one is rather important, and that is that any number, I got some arbitrary splotch or squiggle here, but I raise it to the 0 power, no matter what this is, other than if it's 0, equals 1. Notice I said other than 0. 0 raised to the 0 power is not 1. That's the exception. Otherwise we have 0 equaling 1, and that would throw our whole math system into a bunch of hoopla, I guess. Okay. Now, the next representation here, negative exponents, this is a very important concept, and this will arise in any number of situations in electronics and radio. And you may also see it in exam questions. When we have a value, let's say 2, and we have it to the negative 2, well, we know that 2 squared is 4. But what does this negative mean? This negative, this notation, is a shorthand for this. Whatever number is in front of this 2, and there's only a 1 times this 1 is always invisible. It just means 1 over 2 squared. So this idea of having a negative exponent, then, whatever is being raised to the power, and you look only at the digit that this exponent is next to, then that's the only thing that's being raised to a negative 2. That's just shorthand for this. Now, why are there two ways of doing this? Well, because in using these laws of exponents, this is much harder to cancel out. What if I had 2 to the negative 2 times 3 to the positive 6? And let's change that 3 to a 2, because we're going to be adding exponents here. Should be the same base. These still add. I take a negative 2 and add it to a positive 6. 2 of these guys wipe out 2 of these guys, so I wind up with 2 to the 4th. And if you're unsure about applying these, use your calculator to check up on those. That's the important thing. Okay, so the negative value here then just means that it's in the denominator. If I had an x or an a or some other expression here, that would be up on top. If I had x times 2, this x would be up here on the top. Okay. Lastly, we get fractional exponents. We've all seen things like the square root of some number. This is the square root symbol. If it was a third root, it would look something like this. It'll have a 3 there. This means the third root of 2. But if there's nothing there, it's understood that this radical symbol means square root. This can be written as a fraction. Fractional exponents. It's the power of the numerator, and the bottom tells us the root. So this is another way of writing the square root of 2. So if I had 2 to the 5/3 power, this is the third root of 2 to the 5th. That's what this rule is telling us. Okay, so there it is in a nutshell. You might want to practice this a little bit. Matter of fact, with all these videos, practice, practice, practice. Math takes practice. That's all there is to it. Okay, see you in the next video.